Hello there. My name is Jack Williams, and today we're doing some meteorology wind plotting sheets for Dr. McNee's meteorology class. For our first problem, you can see we're on a course of 0, 0, 0 degrees true at a speed of 15 knots. The wind course, and apparent wind, is 0, 9, 0 degrees relative, and the wind speed is 10 knots. Therefore, our first step for this is going to be plotting the ship straight up. Alright, then make a little hash mark at 10 knots, right, for our own, not 10 knots, I'm at 15 knots for our own ship. Let's get 15 knots down under there. Alright, make a little hash mark up here at 15 knots, showing our own ship's course and speed. Next up, we gotta find the wind speed. We're going to go over here, and we're going to dash out the apparent wind at coming from 0, 9, 0 degrees. Alright, now we're going to transfer that vector, arrow there, transfer this vector over up top to our own ship's course, sliding our triangle up right to the tip of that arrow, and we're going to draw another arrow over this way. Now we got to measure out the wind speed. As you can see, the wind speed is 10 knots, so we're going to take 10 on our divider right here, like that, put that over onto there. Yep. That's 10. Okay. Now right there represents the wind speed relative to our ship. Now our final part of this, you want to take your triangle and put one part on the very tip of the arrow, another part to the origin, or our own ship is where it is, and make sure it stretches all the way across the other side of the plotting sheet, way down here. And you want to draw an arrow back towards the middle, right? Also mark out over here, right in our sex. This arrow right here, go like that, represents the true wind. True wind, as we can see, is a speed of 18 knots. So we're going to mark down 18 knots. And if you go down here, you can see intersected at 146.5 degrees. So 18 knots at 146.5 degrees true. There you go. That's how you solve for wind. For our next problem, we're on a course of 0, 9, 0 degrees true. Speed of 15 knots. And the wind is coming from our stern, or 270 degrees true, at a speed of 3 knots. First step in this problem, again, to mark out our own ship's course and speed, going like this, measuring it out, drawing it out right there. Then taking our dividers, going to 15 knots, marking that out right there. Then draw an arrow. There's your own ship's course and speed. Next up, this problem, because the winds come from the stern, right? You're going to draw a bearing out here, 270 degrees. Make the hash bearing. We want to slide it, but since it's coming from the stern, we don't need to slide it over anywhere. However, you can just imagine that we're sliding it over directly, like our last problem, onto this line. Since the bearing, I gotta measure it out, it's coming from 3 knots. Yeah, take that 3 knots, so you would have imaginary slid over, right? And put it all the way over here. onto our own ship's course and speed. Make a little hash mark for that. Actually, we slid it over from there. Now from here, it's pretty simple. You just measure out the wind distance from there to there, and that should give you 12 knots. Let's mark down 12 knots right here. There we go. Alright, now that we have our wind speed plotted out, you're going to want to go down here to 3 knots. Mark that out. There we go. And imagine that from this point forward, there's an arrow going from there to there, representing our true wind speed. Now, we're going to slide this all the way over to right here, and mark it down. Again, another arrow right there. And since take our dividers, measure this out. That should give us 18 knots. Yep. And 18 knots. Then going back across, you can see if you measure on this thing, on the same bearing, is 270 degrees. So 18 knots at 270 degrees true. Now, since it's coming from the stern, we can also just add the wind speed of our ship's own speed and the wind speed together to get this problem answered. For our final problem, we are on course 085 degrees true. Speed of 8 knots, and the wind speed is coming from a wind course coming from a head coming from 085 degrees true, a wind speed of 18 knots. So, from here, we're going to measure out our ship's own course at 085 degrees true. Pair dividers, go down here, 8 knots, mark that off. And put a little arrow in our own ship's course and speed. Next off, since we know where the wind's coming from, we gotta measure out 085 degrees. We gotta measure out 18 knots. 18 knots on here. We're gonna go all the way out there. We're gonna put 18 knots, being the base of our vector, right here. Now imagine this 18 knots is blowing this way over the ship. Right? So this wind speed is coming back this way. Now we're going to want to take this, because there's not a vector over here, and extend it back this way. Now we can transfer over this 18 knots. And transfer this 18 knots from here and slide it back onto the tip of this vector, putting our new head of our true wind going this way, our relative wind going this way. Now taking this, we can draw going back to the base origin of the ship, our true wind vector going back this way, looking all the way across the plotting sheet over here at 085 degrees true. And if we measure this out, it should be at 10 knots. There we go. And again, looking across the plotting sheet over here at 085 degrees true. There we go. And similar to the last problem, where you could add two together, since the wind's coming from ahead, you can subtract the two. You can subtract speed by wind speed and get the answer. And